All right. So help me out. The graph that's over on the left. Hold on, I want to write down our synonyms first. You guys told me 3 synonyms for solutions. What were those 3 synonyms? Yes, roots, zeros, and what was the last one? X-intercepts. When I'm looking over at the graph on the left, how many roots, how many x-intercepts do you see? 2. There's one right here, and there's one right here. This has 2 real solutions. One of them right here, and one of them right there. Go look at the graph on the right next. I skipped the one in the middle on purpose. We'll come back to it. This one has 1. Right here, there is 1 x-intercept. So 1 real solution. Right there. What about that graph in the middle? Yes, it does not have any x-intercepts, so 0 real solutions. And I'm so excited to hear that you remembered when we have 0 real solutions, that means that we have 2 imaginary solutions. We are going to talk a lot more about this idea of imaginary solutions and imaginary numbers. Let's go down and do number 2 next. It said to simplify the following radicals, so we need to break them down. Do you guys know of any numbers that will go into 54? 6 and 9. So I can break this down to be 6 and 9. Can we break down 6 any more than that?
Yes.
6 is 2 times 3. Okay. So you said 9 is what?
3 and 3.
3 and 3. What kind of a root do we have here? Square root. We're looking for pairs. How do I know if it's not a square root? Little number outside, and then that's how many of a kind I would need. So if it was a cubed root, I'd be looking for 3 of a kind. But I would have to see a little 3 out here. If I don't see a number out there, our index is what? 2. Do I have any 2 of a kind? Yeah, I've got a pair of 3s. What is 3 times 3?
9.
What's the square root of 9? 3. That's why we pull out a single 3. So I'm going to pull out a 3. What about the 2 and the 3? Do we have pairs there? No. So what do I do with those? Multiply them back together. Do they stay under or come out? Stay under. What is 2 times 3?
6.
So 3 square root of 6 is how this simplifies. $96. You said what? 12 and 8, yes. Square root of 12 times 8. Is 12 prime, or can we break it down more? We can break it down. Tell me what goes into 12.
4 and 3.
4 and 3 is the first thing I heard, or you could do 6 and 2. That would be fine. Remember, it doesn't matter how we break these things down. 4 and 3. Tell me about the 8. Can we break that down at all?
Yes, a 4 and a 2.
A 4 and a 2. Do you guys see any pairs?
4 and 4.
4 and 4. I could keep breaking things down, right?
Oh, yeah.
But anytime I see pairs, I can match them up and pull them out. Exactly. It's going to end up being the same thing if I pull them out separately and multiply them together, or if I identify them right here as a pair. What is 4 times 4? 16. What's the square root of 16? 4. That's why we pull out a single 4. What do I do with the 3 and the 2? Multiply them back together, and so I have what under my radical? 6. Awesome. Beautiful work. That is really tight on you. Okay, we are going to be on page 259. I want to talk to you for just a minute before we start in on page 259, though. We are starting Unit 6 today. We will not finish Unit 6 until after we get back from break. It'll be the first part of December until we finish this. Unit 6 brings a lot of ideas back together that we've already talked about. You know how in Unit 2, that's when we talked about how many and what kind of solutions? And we did some quadratic formula and we found the discriminant? We're going to do that stuff again in Unit 6. Unit 5 that we just wrapped up, we were doing square roots and we were breaking things down. We're going to do that again here. There will be no test for Unit 6 by itself. This material will be on the final exam. The reason that we're not going to do a test over Unit 6 is because, like I said, we're not going to finish this up until after break. And if we did a test over Unit 6, we would review, test, and then we'd have like 1, maybe 2 days to review for your final exam, and then take the final exam. That's too much testing all at once, and it's not enough time to review. So instead of doing that, we're going to make sure that we have enough time to review for your final exam, including this material. And like I already said, Unit 6 brings together a lot of the ideas that we've already studied. So it'll be on the final exam, along with some other pieces. Your final exam will be either December 14th, 15th, or 16th. I don't have the schedule yet from administration. I can tell you in the past, when the second period exam normally falls, normally this is on the last day of final exams, so that would be the 16th, and it would be the first exam that morning. I don't know for a fact that that's what it's going to be this year, but in the past, that's what it's looked like. We will have at least 1 day to study each of the units that we've talked about this semester after we finish up Unit 6, before you get to your exam. Okay? All right. Let's talk about this. I want you guys to look at this box that's right down here. You guys see this one? Look at the numbers that are inside there. 4 and -5 and 0.7. 2/3 square root of 2. Are these numbers that you guys have been able to put in your calculators in the past? Yeah. These are all real numbers. These are real numbers. The box right above that, what do you notice each of those has with it? An I. It looks like a variable, but it's actually not. We're going to treat it a lot like a variable. It's going to behave a lot like a variable. These are imaginary numbers. They're called imaginary numbers, but it's not because they don't really exist. They're called imaginary numbers because when we first came upon them, when we first started investigating these, we were like, I wonder what would happen if I'm going to imagine that I can keep going with this. And it turns out that imaginary numbers have very real, very important applications. Everything that you have that uses electricity, the way we've figured that out, the way we know how it's going to work so that we can keep building new and more interesting things, it all has to do with imaginary numbers. I don't completely understand it because I'm not an electrical engineer, but I do know that when I had to study these, they talked a lot about electronics. When my husband studied electronics for his physics stuff, he had to work a lot with imaginary numbers. This is why we study them. They have very, very real applications. When we take imaginary numbers and put them together with real numbers, we call them complex numbers. Complex numbers have a real part, something that you could put into your calculator, and then they have an imaginary part, something with an I with it. Every complex number has a real part and an imaginary part. Today and tomorrow, we're going to focus on how to work with complex numbers, how to add them, how to subtract them, and how to multiply them. It works almost exactly the same as binomials that have x's with them. For adding and subtracting, it's exactly the same. Multiplying, it's almost the same. Look down at the bottom part of the page, number 2. You guys have a good bit of room down there, right? Off to the side, I want you to write this problem. 2 plus 3x minus 5 minus 7x. That looks a lot like what they have printed, doesn't it? What's the only difference between what I wrote and what's printed on your page? X's versus the I's. If we do this with X's, what would I need to do first? Not equal to 0. I'm going to distribute, not double distribute though. I need to distribute this negative because we're going to be subtracting. What's negative when I distribute it to a 5? Negative 5. What do I get when I distribute a negative to a number that's already negative? Turns it into a positive. So this is going to become a plus 7x. Nothing changed about my 2 plus 3x. We can combine like terms. What are the like terms that I can be combining? 2 and negative 5. What do I get when I combine a 2 and a negative 5 together? Negative 3. Yes, 3x and 7x I can combine together and get a 10x. Positive or negative 10x? Positive 10x. That is the exact same process that I'm going to follow over here when it has the i's with it. What's the first thing we did when it had the x's? Distributed the negative. Let's do that here. I'm going to distribute my negative. What would that give me? Negative 5 and a positive 7i. I'm going to bring down the 2 and the plus 3i. What can I do next? Combine like terms. What are the like terms that I can be combining? 2 and negative 5, and that'll give me what? Negative 3. And then 3i and 7i plus 10i. So here's the thing about complex numbers. Most of the time when we work with x's, we want our piece that has the x in the front, right? When we're working with complex numbers, we want the imaginary part, the part with the I, at the back of the number. So I'm going to put the real part first, Real number goes first, and the imaginary number goes second. How are we feeling? You guys feel like you can try a couple more of these? All right, turn the page for me. We've got a couple practice problems here, but then they've also given us a bank of choices. For this first one, what do they want us to add together? 3i and 7i. What do I get if I add 3i and 7i? 10i. Beautiful. Is that one of my choices up above? Yes, it is, right here. Second one down, they've given me part of the answer already. What have they given me? The 3. Where did that come from on the other side? One in the parentheses. And they're adding that, right? So what do I need to do over here? Combine. What am I combining? 2i and 8i. Am I going to add or subtract the 8i? Add. I'm adding, and then it's a positive 8i. What do I get when I add the 2i and the 8i? 10i. I used that choice again. Look at me go. Distribute the negative in the next one down. What do I get when I distribute that negative? Negative 5 and negative 3i. What pieces can we be combining? 3 and negative 5. What will that combine to give me? Negative 2. Anything else I can combine? I and negative 3i. What do I get when I combine those together? Negative 2i. Is that one of the choices from up above? Yes, it is. Right here. For this one down here, they told me the answer, right? And I have one of the pieces that was being added. Think about this for just 1 second. If I had blank box plus 7 equals 10, how would I figure that out?
Subtract.
I can subtract. Can I use that same idea here? Yeah. What can I do?
4 minus 7.
Yep, I can subtract 4 from both sides. What would that give me? 3. What else can I do? Yep. Subtract the 2i here. What would that be? Negative I. Is that one of the choices from up above? Yes. Last one here. They tell me the answer. What do you notice about that answer? It's just 7i. Is that real or imaginary? Imaginary. Does it have a real part? The 7 and the I together make the imaginary. When I talk about a real part, that would be like this part right here. So this is only imaginary. Over here on the other side of the equal sign, does that part inside the parentheses have a real part?
Yes.
But the answer doesn't have a real part, so what does that mean happened?
It needs to be canceled out, so it should be subtracted 4.
Yeah, this has to have a minus 4 because it obviously canceled out because it's not part of my answer over here. And then what's the imaginary part that I see on the other side? Negative 3i. But when I combine it with whatever this is, I get 7i.
It needs to be positive.
Positive 10.
7 plus negative 3 plus positive 10 comes out to positive 7.
So just like this,
I.
I. Is this one of my options up above? Yes, it is. Give me a real quick thumbs up, thumbs down, or in the middle. How you feeling about adding and subtracting? Yes, ma'am.
Can you explain that last one again?
Yeah. So similar to what I did up above, it came out to give me 7i.
You just add them together.
Mm-hmm. So I subtract it. And then this is a positive 3i. So I would add the 3i, and these are like terms. So when I combine those together, I get the 10i. Does that make sense? Yeah. All right. Look down in the middle of the page for me. Middle of the page. Do you guys remember on the bell work how we were breaking down square roots? We're going to do that here again. And I'm going to tell you something special about I. I is my imaginary number. I is equal to the square root of -1. Do you guys remember in the last unit when we were graphing the square roots? Could we do the graphs with -1?
Wait, huh?
Do you remember our square root graphs? Could I have -1 on the x side?
No.
No, because if you do the square root of -1 on your calculator, what happened?
You get -1.
Undefined, we got an error. We can't do the square root of negative numbers. Yes, if you multiply it by itself, it comes out to be a positive. We can't do the square roots of negatives. So this is the thing that mathematicians looked at. Because they're like, well, we can't do the square root of a negative number. But what if we could? What if we could do the square root of a negative number? And so they named it I. And then they're like, what could I do if I could get that negative out, if I could call it I, and I could keep going with these math problems? That's where this comes from. And again, it does have very real applications. So I want to practice this idea as we're breaking down these square roots. To do the square root of -4, I can break that down, and I can say, well, -4 is -1 times 4, right? If I do -1 times 4, I get -4. Can I break down 4 anymore?
Yeah.
Yeah, that's what times what? 2 times 2. Can I make a pair?
Yeah.
I can make a pair of 2's. 2 times 2 is 4. The square root of 4 is 2. So I know I can take a 2 out of here. And here's the new thing we're learning how to do. This is the square root of -1, right? It doesn't make a pair, but that is the same thing as I. So I can bring that out as I. So anytime we have a negative under the square root, we can take that I out, and then we just keep breaking it down the way we've been doing. Look at the one in the middle. Square root of -10. -1 times 10. Can I break down the 10 any more than that? 5 times 2. I got to stop there. I can't break down 5 more. I can't break down 2 more. Can I make any pairs? No. But I do have this. What can I do with the square root of -1? Make it an I. We're going to bring it out as an I. 5 times 2, I just have to multiply back together, and I leave that as the square root of 10. And then on the back side of it, but not underneath it, I have an I. When we have imaginary numbers, we always put them at the back. So we always put the I at the back. You with me, Micah? Part C. Does anybody remember how to do the square root of fractions? Yeah, we're going to do the square root of the numerator over the square root of the denominator. We can almost like distribute it. So what do I have on the bottom? 4. My numerator, I have a -9 under there. Can I break down -9 at all? because that's -1 times 9, right? Can we do the square root of 9? Yeah, I got 3 and 3 there. So I've got -1 times 3 times 3 over 4. Can we make pairs? What can I make a pair of? 3 and 3. When I multiply those together, I get 9. Square root of 9 is 3. What else can I do that's new? Yeah, this right here. You can put it next to the 3, or you can just put it behind the fraction. That would be fine also. It can go in the numerator, or it can just go at the back. All right. We are going to learn how to multiply these two things together. We're going to rewrite each of these in terms of I first. So if I look at the square root of -5, tell me how to break that down. -1 times 5. Can I make any pairs? No. But what can I do? -1 out, I can bring out as an I. So I would have the square root of 5I, like this. What can I do with the square root of -2? How can I break that down? Not just 1 and 2, but -1 times 2. Can I bring anything out? -1 can come out as I. So I'd have the square root of 2I. Do you guys remember how to multiply things that are under square roots? Yeah. If it's under a square root, like the 5 and the 2, I can just multiply those pieces together. So I can do 5 times 2 under my square root. What about things that are not under square roots? I can multiply those together, so I would get I squared. Underneath the radical, what would I get when I do 5 times 2? 10. And then I have I squared. What did I tell you guys up above I was equal to? The square root of -1. I'm going to do a substitution. I'm going to do a replacement. Where I wrote that I'm going to write it down as the square root of -1. What did we just learn in the last unit happens when I square a square root? Yeah. It cancels out. So what would that leave me with then? -1. Question.
But don't you gotta do something to the other side? Or no?
We will in just a second. If I had 10 times -1, what would that give me? -10. So what do I get here when I do the square root of 10 times -1? It is possible. It's not under my radical anymore. 10 times -1, you said would be -10, right? The square root of 10 times -1 would give me negative square root of 10. The negative would be on the outside because this is on the outside. Turn the page for me. We've talked about adding imaginary numbers. We've talked about subtracting imaginary numbers. It works just like when there's an x. Now what are we going to do with it? Multiplication. So off to the side, give yourself some room. I want you to write down 3 minus 2x times 5 plus 4x. We're going to remind ourselves how this works with x's. And then we're going to apply that idea to the imaginaries. What do I do when I multiply binomials? Double distribute. So I'm going to take the 3 and distribute it to both pieces. What would that give me? 15 plus 12x. And then I need to do what? Yep, same thing with the other one. So negative 2x gets distributed. What would that give me? Negative 10x. Negative 8x squared, because I have x times x. Is there anything that I can combine together? Yep, positive 12x, negative 10x, 2x. That's as much as I can do with x's, right? Let's go do that exact same thing with my complex numbers. Tell me where to start. Double distribute. So I'm going to distribute the 3. What would that give me? 15 plus 12i minus 10i minus 8i squared. Can we combine anything? Those two together. So I would have 15 yep, minus 8i squared. Here's where it gets just a little bit different. What does I equal again? I is equal to the square root of negative 1. So this I squared right here, I'm going to put the square root of negative 1 there. Because what happens when we square a square root? Cancels out. So this would be 15 plus 2i minus 8 times what? Negative 1. What's negative 8 times negative 1?
8.
Positive 8. Do I have all of my like terms combined?
No.
I could, except that's not being squared, so it's not going to simplify anymore. Good question. I can combine the 15 and the 8 together. What's 15 plus 8? 23. So this is 23 plus 2i. Whenever you see an I squared, what number can we replace it with? Whenever you see an I squared, negative 1. I'm going to make a note of that right here. Whenever you see I squared, replace with negative 1. Always, 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 always. That is the only way our complex numbers are different than just doing this with x's. Let's look down at number 7 and 8, and then we'll wrap it up. What do they want me to do on number 7? Sums and differences. Sums mean to do what?
Subtract.
Sum means to add, and difference? Subtract. Do I have to distribute things when I want to just add two numbers together?
No.
So tell me how to do part A.
5 plus 2.
5 plus 2, which would give me 7.
And then 8 minus 3, which gives you 5.
8 minus 3,
5i.
5i. Do I need to distribute anything on part B?
No.
What's in front of that second set of parentheses? The negative. I do need to distribute this. So minus 4 minus 12i combine my like terms. What are the like terms we're going to combine? 12i and negative 12i is a 0. Those will cancel. So what do I get when I combine the other pieces? Negative 7. Is that complex anymore?
No.
No, the imaginary part canceled out, and I'm only left with the real part. What are we doing on number 8? Multiplying. It says product. That means to multiply. How do we multiply these things? Double distribution. So I'm going to take the 5 and distribute it. What do I get when I do that? 10. Negative 15i. And then I need to distribute here. And what do I get? 16i. Positive or negative? Negative 24i squared. Any like terms? Yep. 15i and 16i. That would give me 1i. Is there any replacement that I can make? The I squared I can replace with what? Negative 1. When you see I squared, we replace it with negative 1. What's negative 24 times negative 1? Positive 24. Are there any other like terms that I can combine now? 24 and 10. So I have 34 plus I. Let's do one more and then we'll be done. Help me double distribute here. So I have negative 12 minus 36i. And then what?
12 into 4 is 48.
Plus 48i. Yep. Plus 144i squared. I know I can put these two things together. What would that give me? Negative 36 and positive 48. Yep, it is positive 12i. What replacement can I make? Yep, we're going to replace this with a negative 1. So I have 144 times negative 1. Negative 144. Yep, negative 156 plus 12i. Beautiful, beautiful work, guys. We're going to keep practicing this exact same skill on Monday. Your complex numbers homework isn't due until Tuesday, so we'll just keep practicing these exact same skills on Monday. Have a fantastic weekend, everybody. Very nice work today. I am super proud of you guys.